All right, so 4.06 is on transforming quadratic functions. We have transformed other functions in the past, but those were linear. But these are the same transformations, all right? We're going to think about, remember how we could look at a parent function, we called it? So the parent function for quadratics is just that y equals x squared. Or maybe sometimes you see it as f of x equals x squared, right? So they could write it either way. We know that it means the same thing. Either way, the f of x or the y is our output, right? And so you'll see it written both ways. And then remember we had these vertical shifts up and down, and we had horizontal shifts left and right. We also had where it could flip over across different axes if you had a negative number in front, different things like that. So all those transformations we have talked about already this year with linear functions, and they are on the Padlet from earlier last semester. But I've also put under our Unit 4 for our second semester the rules for these transformations as well. So that would definitely be somewhere that you want to check out for those rules. All right, so what I wanted us to do for just a quick warm-up and just to kind of refresh our memories on these is to check out Desmos, and we're going to type these in and actually see the transformation. So the first thing that I want you to have is the parent function, and then we're going to do these just one at a time to see that shift, to see that transformation, okay? Hey, Rory. So, yeah, we're going to review a couple minutes, and then I'm going to give you guys time to work on it again. So if you want to, stick around and just get a quick little refresher, and then hopefully you'll understand it a little bit better to take the quiz again. All right. So let's go ahead and click on the Desmos link. Let me get that into the chat for you too, just in case you need it there. And so you're going to, go ahead and type in the parent function first, okay? Type in the parent function first. So just that, you could type it in as y equals x squared or f of x equals x squared. It doesn't matter. I'm just going to type in y. Remember, there's that little calculator keypad at the bottom left where you can do your exponent. And then type in the second one, the y equals x squared minus 1. And let's see what that does. So let me show you what I have typed in just so you can see. I like Desmos how it color codes it too, so you always know like which which line matches up with which function. All right, so this is what you have. Right, so type in, so this is my parent function. I'm just going to leave this one the whole time, but I'm going to change this one. We're going to go through individually and do each one of these. So I want you to tell me what happened. The minus 1. So we're doing this one first. Minus 1. If you subtract 1 and it's at the end of the function there, what happened? Yeah, I think it should go down 1. So double check. So the x squared, it's beautiful. It's right going, it's at the origin. It's through that middle point. Well, not really through the middle point, but it's at the origin, right? And then, so mine, I don't know if your colors are the same, but my red one is my parent function. And then the blue one, yeah, it looks like it shifts down, doesn't it? So you can see how here's the red, and here's my parent function. Here's the original one. When I type in that parent function, but I subtract 1 from it, it shifts down 1 unit. It is a vertical shift down 1. Yep. Okay. So what do you think is going to happen? It's going to we're going to be like, oh, yeah, I remember this, right? Hopefully, fingers crossed. So what do you think is going to happen if we change this to a +1? I'm going to go in and change mine to a +1. So leave the parent function in there, but what happens when you change that minus to +1? It's going to go up 1. Yes, Brady, you got it, Brooklyn. Yes, Cassidy. Good, Caleb. Yep, Christian, that vertical shift. Good. Up 1, Jordan says. And Melody, yes, Ansley, it's going to move up. So remember, when it's at the end there, for that +1, oops, what's this one here? Change that to a plus. There we go. All right, so here's our parent function, still staying in the same place, right? But when we add 1 to it, to the end there, we have a vertical shift. It just bumps up 1. Everything else stays the same, but the graph has that vertical shift of 1. Yes. Yeah, so the red is our parent function, and the blue ones, those are the children. So we're on a scale of 2. So, I mean, it does have like little, you know, that's just our grid marks, but it's on a scale of 2. So here's 2, so, and it went halfway, so that's up 1. Yeah. So don't count the little individual lines. That's a good point. Just look at how it's counting here. Remember, you can zoom in and out. So if you need to zoom out a little bit, or no, we would zoom in a little bit, that plus sign, I could make it a scale of 1, but then you get even more little grid lines. Then I have like 1, 2, 3, 4, like 5 grid lines instead of just the 4. So, but then it's on a scale of 1. So totally up to you. You know, play around with Desmos a little bit, zoom in and out, use the little keypad, all of that will help you. Okay, so if we have the -1 or +1 at the end of that x squared, then that shifts it down or up, right? So we could have -3 and it would have gone down 3 from the parent function. We could have +5 and it would have gone all the way up here, right? So that's what that shift is going to tell us. Do you guys remember if it's inside the parentheses, if it's actually with our input, what would this -2 and +2 do? Let me clear these off and we'll start again. What do those do? To the right or the left? Yes, you got it, Melody. Yep, Hayden, exactly. It's going to move it to the left or right. We're going to have those horizontal shifts when we have that minus and plus here. You got it. Who remembers which sign does what? So if I have a -2, what is that going to do? If I have a -2, yes, awesome. Remember, those were kind of backwards, weren't they? So if it's a minus, it's actually going to go to the right. We have to kind of think backwards on these, they're opposites. And if it's a plus something there with the input, it's going to go to the left. You guys got it. Do you remember that from a while back? Looks like most of you did, or maybe you went through the lesson as a good refresher, right? So you do have to remember that those are kind of opposite of what we normally would think. Normally we'd think something's plus, it's going to go to the right because those are positive, but the original equation is x minus that number. So then when you put in the positive, it just stays negative, but then when you subtract the number, it actually switches to a positive. So that's where those signs work out like that. All right, so let's put these in here. Let's see what this looks like. I can check my year-to-date file. Ready? I'll have to do But I think you have to type it in all again. I tried to just adjust mine, but it wasn't working. Let me try to adjust it. Okay, so x minus 2, and that's all to the second power. Gives me a nice straight line until I put the second power in. Up there we go. Oh, I like these colors. We've got red and purple. All right, so here's what it looks like when we type it into Desmos, right? And then, so the red is that parent function. And we see it shifted 2 to the right. Awesome, yep, good. So here's our original, here's our parent function still hanging out at the origin. But when we take that input and we subtract 2 from it, it actually shifts it 2 to the right. All right. All right, so how are we doing so far? Are these shifts coming back a little bit? I know it's been a while, but you know, use Desmos as a tool too, for sure. Like, I mean, you know, we've got it, we might as well use it. Technology can be our friend sometimes. All right, so what happens if you switch that minus to a plus? So if we switch that to a plus here, yep, it's going to go 2 to the left. And again, I know it's kind of, we're like, why? It's addition, it's positive, it's plus. Why are we going to the left? But remember, the original equation does have that negative built in. So then when you put the negative in to shift it to the left anyway, it does switch to the positive. So that's where those opposite signs come in. So now I've got the plus 2. Here's the parent function again, and it shifts 2 to the left, or whatever that number might be in there, in the parentheses with the input there. All right, so that's just kind of a quick refresher. That will definitely, you know, help some of us think about these shifts as well. So let me pause here. Just what questions or comments do you have so far? Okay, not seeing anything come in quite yet. So let's look at a couple examples, okay? Let's try a few examples here. All right, here we go. And then I'm going to give you guys time to work, like I said, but I'll be in here to, you know, answer questions. But I wanted to kind of quickly review, because you should have already gone through the lesson on your own anyway. But I know, you know, it makes it a little easier when we go through some examples together too, and you have the opportunity to ask questions, not just, you know, be sitting there on the OHS lesson on your own. So I wanted to kind of, you know, quickly review, then give you time to work, but I'll be here if you are going through the quiz again and have a specific question, you know, and we can look at it together. All right, so I did put this up on the Padlet. So this is another just kind of nice little visual, color-coded, right? So the blue is all the parent functions. You can see that's always like right in the middle there. And then you can see the shifts that happen. So the other ones that we have also are stretches and compressions. So when you see something stretch, remember you have that A in front of it. And that can, if it's greater than 1, so if it's 1 or bigger, then that's going to actually make it, you know, stretch here. If it is between 0 and 1, so usually you'll see a fraction number there, then it's going to compress. You can see the green here. And then the other one that sometimes you see is the reflection across the x-axis, and that's if you end up with a negative here in front of your input. It will just flip over. Okay, so those are some other ones to think about too, but this is also on the Padlet, this helpful little page. All right, so what transformation takes, I'm going to turn off the chat for a minute. So let's use our polling options for this one. I'm going to hide the responses just so everybody can look at it for a second. So what transformation takes place if we know that our parent function is f of x equals x squared minus 4, and then our g of x is this x plus 3 to the second power minus 4. How did it change from the original function to the new one, and what kind of shift or what kind of transformation happened there? I'm just going to label these A, B, C, and D and give you a minute to think about that. Look at the original one that you're given and see what changed. That's your biggest thing. You want to see how did it change from the first one to the second one. All right, how are we doing? So look at this one. This one is the parent function. The f of x is the parent function in this situation, x squared minus 4. Then the new function, g of x, is x plus 3 squared minus 4. So how did it change going from f of x to g of x, and what kind of transformation would that have been? Go ahead and take a minute. I've got most of you. The big thing is to see what is different from one to the other. And then a couple of you some chat. Might need to double check your answer. All right. So what happened here? X squared minus 4 to x plus 3 squared minus 4. What is the difference from f of x to g of x? Maybe even like lining them up underneath each other could be helpful. I don't know. Whatever, write them down underneath each other. Let me do that. Let me put them up here. So we have this one, and then we have this one. We want to see how it changed. What is the difference? They are not the same. One transformed a little bit. What is different here? The plus 3. Yes, Christian. Yeah, the x squared technically is the same. The minus 4, that stayed the same. The plus 3 here in the parentheses, so it went with our input, we added that with our input, is what changed. If we have plus 3 in those parentheses, what does that do to our parent function? What kind of transformation is that? It does, Brooklyn. Yep, you got it, Anya. Yep, exactly, Hayden. Oh, sorry, Anya. You're looking at the -4. I said that too quickly. The -4 moves it down, but that was the same in both equations. That didn't change. It was this +3 that we added to our input here. Yep, you got it, Rory. Yeah, it goes to the left. There you go. Thank you, Riley. So the correct answer here would be A. So it goes 3 to the left. 3 to the left. Remember, that's the opposite sign. So because it was plus that, it's going to shift to the left. Use these. Okay, it had here, you can see how this has parentheses. And if it's minus, it says it shifts to the right. If it's plus, it says it shifts to the left. Did anyone try to put it into Desmos to see it that way also? Okay, good, Rory. Yeah, so you can use that too. Like I would try to use the chart and then check yourself in Desmos, right? Just to make sure that you're understanding it. Okay, awesome. Let's look at this next one. So 16 of you answered that one correctly. Let's see if we can get a better one on this one. All right, so here's our parent function, g of x. This is what we're starting with. Here's h of x. This one's a little bit tougher. To think about this one a little bit more. To think about how it changed. Use process of elimination, like get rid of the ones that you know aren't correct. Also is a good trick, right? Not really a trick, I guess a good tip. Okay, what happened here? Think about this one for a minute. What answers can we, oh good, Christian, yep. It's not a straight line because they're both squared. So we see they're both quadratic. We know they're both going to be parabolas. So they'll both be parabolas because we have that x squared. Those are quadratic. Ooh, a lot of you getting this one. What changed? We have x squared minus 5 and x squared minus 1. It went from a -5 to a -1, or a -5 to a -1, exactly. So think about if you have that parent function x squared, right? And you know that's right in the middle, that's at the origin. Okay? So even without Desmos, you can kind of visualize this one, right? So without anything there, the original parent function would be similar to this. It would be going through the origin, right? Then we shifted down 5. 1, 2, 3, 4, 5. So then it shifted down 5 because it was a -5. So then it would have looked something like this. Not perfect, but you know, just trying to get a visual here, right? Well, how many units does the -1 go down? If it's x squared minus 1, it's just going to be shifting down 1 unit. So if I was here originally, I was at the -5 originally, but then my new function is -1, what happened to go from here to here? It moved up 4 units. Yeah, and the way that you can also think about it is -5 plus what gives me -1, right? Some of you might have thought about it like that too. So -5 plus 4 gives me -1, and so plus 4 would have moved me up those 4 units. We had 16 people answer this one correctly too. All right, so we're hanging in there. Did anyone use Desmos to see it again? So again, you have that tool, use it. Okay, good, awesome. Think of it, try to figure it out, use what you know, but then check yourself, okay? Let's look at one more, and then I'm gonna have you guys jump in and try the quiz again, and I'll be here to help you out if you need it. So this one's a little bit different. We just keep adding a little bit more, right? So this one has 2 transformations. I'm going to actually copy this one and put it underneath. Let me copy the g of x. So the f of x is our original equation. And then we've got this g of x down here. So see what changed. What changed besides the f and the g? That doesn't help us. Let me clear out those polling options. So it looks like 1/2 x minus 3 minus 6 plus 5 plus 3. So think about what those shifts are going to do. Go ahead and look at that one for a minute. You know what? I'll eliminate these last 2. That's a lot of choices, and neither one of those are right. So let's just stick with A, B, C, and D. We'll stick with A, B, C, and D. And what changed from our original function to the new one, from f of x to g of x? Think about it. Remember how on the last one I said, okay, I was like -5 plus what gives me -1. Think of it like that too. That might be helpful. And so -3, how do I get to a -6? And what would that have done to my graph? +5 to +3. What number got added there? And what does that do to my graph? Take about one more minute because then I want you guys to have time to get into your quiz as well. Okay, how are we doing? All right, let's check it out. So most of you have A. A is the correct answer. So does anyone want to explain to me? Yep, this is 4.06, Melody. Can anyone explain to me what happens? Why A is the correct answer? How did we go? So the 1/2 was the same. How did we go from -3 to a -6? -3 plus what gives us -6? So -3 plus what gives us -6? If our original graph was at -3, so that means we were to the right 3, how would we get to that -6? How would it shift over here? We went 3 to the right, but we know that that's -3, right? Because those signs are opposite. Yep, -3 plus -3 gives us a -6. So we had to go 3 more units to the right, but we know that those horizontal shifts, those signs have to be opposite. Okay, so this, what, 3 units. What about going from 5 to 3? 5 plus what gives us a 3? So we have to be thinking of positives and negatives here. 5 plus what gives us 3? No, 5 plus 2 would give me 7. A -2, there we go. We need a -2. So this is our vertical shift, up and down. So if I started at 5, but I subtracted 2, what is that going to do to my original graph? Is it going to move it up or down? If I had to go, if I went -2, yes, it's going to move it down 2 units. So A is the correct answer. So break it apart, little pieces, you know, at a time too. Like just look at the horizontal shifts first. Think of that one. Then just look at the vertical shifts. Think of that separate if you need to, okay? And then you can double check yourself in Desmos as well, but just break it apart. Use the Padlet as well, all right? So those are the kinds of things that you want to be thinking about, those horizontal, vertical. Don't forget that we can also have stretches and compressions. That's based on if that A, that number in front, is greater than 1, or if it's less than 1, but greater than 0. So we're looking for fractions here, okay? So be on the lookout for fractions. Like this one here had that 1/2 in front. That would have told me that it was a compression. Okay, and then the other thing that you can also think about is if you have a negative in the front of your input there, it can also reflect across the x-axis. All right, so I'm going to have you guys go ahead and start looking at that 4.06 quiz again.